Hello everyone. In this video, we will discuss about the concept of testing of hypothesis with the help of some applications. So, what is the need of testing of hypothesis? Usually, we have a very large population, and because of some time and money resources, limited resources, we have to take sample from this population, and on the basis of this sample we want to estimate something about our population. So here the role of inference comes into account. The most important thing is our sample must be representative of the population. If our sample itself is not the proper representation of the population, then whatever analysis we will use, it will not lead to the correct results about the population. Okay, so there are many sampling methods for this and that we can discuss sometime if you are interested. Then on once the sample is collected, which is truly representative of the population, we have to perform some exploratory data analysis about our sample, and then we have to compute the estimations of for our main objective, and on the basis of this sample estimates we try to infer something about our population. So here is the role of inference. The first thing in inference is hypothesis, because this is hypothesis which we wanted to test. Now the question is, what is hypothesis? Hypothesis is a statement which we wanted to test. It can be anything like is there any correlation between height of a father and height of a son? So this is my research question. I can formulate my hypothesis, that means my statement which I wanted to test as, yes, there is a positive correlation between height of a father and height of a son. Now this is my perception. Okay, I wanted to test it. Okay, so this is my hypothesis. For example, hypothesis is of two types: null hypothesis and alternative hypothesis. Null, as its name suggests, null means no difference. Okay, so null hypothesis is hypothesis of no difference. In my example, null hypothesis will be there is no correlation between height of a father and height of a son. Alternative hypothesis is opposite to the null hypothesis. So in my example, alternative hypothesis will be there is a correlation between height of a father and height of a son. Let us understand with the help of one more example. So one more thing, null hypothesis is represented by H naught and alternative hypothesis is represented by H1 or HA. Okay, so suppose the null hypothesis is average systolic blood pressure of participants is 120 mmHg. So its alternative hypothesis can be of two types, one-sided and two-sided. Here it is, one-sided and two-sided. Two-sided means we are not sure it is greater than 120 or less than 120. So we simply wanted to test it is not equal to 120. When we are using this not equal to sign, that means it can be greater than or less than. Okay, so that means this is two-sided alternative hypothesis. It can be one-sided also. Like I can specify the direction. Systolic blood pressure of participants is greater than 120 mmHg or systolic blood pressure of participants is less than 120 mmHg. Okay, so this will be the one-tail hypothesis. One-tail alternative hypothesis. And if we are using simply not equal to, then it will be a two-tail alternative hypothesis. Again, here the null hypothesis can be there is no correlation between height of a father and height of a son. So correlation coefficient is represented by small r. Mathematically, we can write H naught r is equal to 0, and its alternative hypothesis will be H1 r is not equal to 0. The moment we are saying r is not equal to 0, this is two-sided or two-tailed. If I am writing here r is greater than 0 or r is less than 0, that means I am specifying the direction. Then it will be a one-tailed alternative hypothesis. The next important concept is test statistic. Test statistic is a value calculated from a sample to decide whether to accept or reject the null hypothesis and varies between tests. The test statistic compares differences between the samples or between observed and expected values when the null hypothesis is true. This is very important slide and it has four very important concept of testing of hypothesis, which is type 1 error, type 2 error, level of significance and power of the test. So there are two things. One is reality, which means here which indicates actual situation, and one is our decision, that is statistical decision. And in inference we have to take a decision about the null hypothesis. Okay, so whether we reject the null hypothesis or we do not reject the null hypothesis. So this will be my statistical decision. So here these are the two possibilities for statistical decision: reject the null hypothesis or do not reject the null hypothesis. Similarly, in reality, null hypothesis will be true or false. Okay, so in actual situation also there will be two possibilities: null hypothesis true or null hypothesis false. Now there are two ways we can take a correct decision, and there are two ways we can take a wrong decision. Okay, the moment we are taking a correct decision, this is known as confidence and power. And when we are taking a wrong decisions, the one is known as type 1 error, or also known as alpha or false positive, and the other one is known as type 2 error or beta or false negatives. Okay, so first talk about the correct decisions. The first one is confidence. Confidence is 1 minus alpha. So if alpha is 5%, then 1 minus alpha is 1 minus 5%, means 1 minus 0.05. That means 0.95, or in percentage this is 95%. Okay, so what it is? This is do not reject the null hypothesis when null hypothesis is true. Okay, you can remember it by saying that we need confidence to say right to right. Okay, so here also we are saying right to right. Now we are not rejecting the null hypothesis when it is true, which is the correct decision. This is known as confidence. Similarly, the another correct decision can be reject the null hypothesis when it is false. So we are saying wrong to wrong, and for that we need power also. Okay, I mean we can easily learn by using these phrases. Okay, so power is denoted by 1 minus beta, and now we can talk about the two types of errors: type 1 error and type 2 error. Type 1 error is rejecting the null hypothesis when it is true, and type 2 error is do not reject the null hypothesis when it is false. And level of significance is the probability of rejecting the null hypothesis when it is true. That means it is the probability of type 1 error. Now we can consider one example of a court case. Here the hypothesis is 1 minute. Members of a jury have to decide whether a person is guilty or innocent based on evidence presented to them. So here the null hypothesis can be the person is innocent. Why we are writing the person is innocent? Because null hypothesis means no difference. The moment we are writing the person is innocent, that means indirectly we are saying that there is no difference between the person and the other persons. Okay, so that is why we are writing here the person is innocent. The concept is same, so don't get confused. Alternative hypothesis can be the person is not innocent. In this case, type 1 error can be we found person guilty when the person was innocent. Type 2 error can be person is guilty actually but court proves him innocent. Confidence level, which is 1 minus alpha, is person is actually innocent and court also proves him innocent. 1 minus beta, which is power of the test, will be when person is actually guilty and court also proves him guilty. Level of significance is the probability of type 1 error. So probability that we found person guilty when the person was innocent will be the level of significance in this particular example. So every time we should understand that in our particular scenario, whether it is related to environmental science or any other field, we should be able to convert these terminologies of statistics into our research problems like we did here for court case. Another example of it can be the null hypothesis. We can consider null hypothesis as effect of drug A is equal to effect of drug B. An alternative will be effect of drug A is not equal to effect of drug B. In this case, type 1 error will be we found that effect of drug A is not equal to effect of drug B, but actually both are equally effective. Type 2 error will be we found no difference in both the treatments while actually effect of drug A is not equal to effect of drug B, and like that. Okay, so let us consider one more example. There is no correlation between ice cream sales and temperature of the day. Alternative can be there is a correlation between ice cream sales and temperature of the day. So in this also we can translate our these terminologies of type 1, type 2 error and confidence and power. Another very important concept is p-value. Nowadays we frequently use p-value to accept or do not accept our null hypothesis. Okay, so what it is? It determines how likely it is that the observed effect in the sample is due to chance. It is the probability of obtaining the study results by chance if the null hypothesis is true. Smallest the value of alpha, the observed sample will reject the null hypothesis. A significant result is when the p-value is less than the chosen level of significance. So in most of the cases, we take level of significance as 5%, but we can take as 1% or 10% as per our scenario. For example, a p-value of 0.02 indicates that there is only 2% chance of getting observed difference by chance. There are two types of test available, like parametric as well as non-parametric test. Parametric tests are based upon some assumptions about the population, while non-parametric test has no assumptions are made regarding the population. Parametric can be performed only on interval or ratio scale data, while non-parametric can be performed even on ordinal scale data. Parametric tests have more power as compared to non-parametric tests. In parametric test, we test mean, while in non-parametric test, we test median. Another important concept is confidence interval. A confidence interval calculated from a given set of sample data gives an estimated range of values which is likely to include an unknown population parameter. The confidence interval expresses two numbers known as confidence limit, the lower limit and the upper limit. This range with a certain level of confidence carries the true but unknown value of a measured variable in the population. The 95% confidence interval is defined as a range of values for a variable of interest constructed so that this range has a 95% probability of including the true value of the variable. According to Brinton and colleagues 2004, they studied a group of infertile patients who underwent evaluation for infertility and reported a significantly higher rate of ovarian cancer among them than in the general population. So the standardized incidence ratio is 1.98 with 95% confidence interval of 1.4 to 2.6. That means infertile females have an ovarian cancer incidence that is 1.98 times higher than non-infertile females. We are 95% confident that the true incidence ratio in all infertile female population lies somewhere in between 1.4 and 2.6. Putting in mind that we are only 95% confidence, it is apparent that there is 5% probability that we are wrong. That is 5% probability that the true incidence ratio might lie either below or above the two confidence limit, which is here 1.4 and 2.6. So there is 5% chance that we are getting the true incidence ratio below 1.4 or above 2.6. Although having the same level of certainty in ruling out chance as the p-value, the confidence limit here gave us some extra information. This information is the lowest and the largest effect that are likely to occur for studied variables. Now the another important thing is the width of the confidence interval. Width means the difference between the upper limit and the lower limit. So as a general rule, the narrower is the confidence interval, better it is. Suppose first study reported the average age of menopause to be 49.5 years with 95% CI of 41 to 59 years. And second study reported the average age to be 50.5 years with 95% confidence interval of 48 to 53 years. Now, which study seems more promising? Obviously, second one, because in second one, there is a narrower confidence interval as compared to the first one. There are various factors affecting the width of the confidence interval. These are confidence level, sample size, and variability. The width of CI varies directly with the confidence level. So a 99% CI would be wider than the corresponding 95% CI from the same sample. This stands to reason since a larger probability of containing the true population value would lie with the wider interval. Sample size and the width of the CI. A larger sample size expectedly will lead to a better estimate of the population parameter, and this is reflected in a narrower confidence interval. So that means the width of CI is inversely related to the sample size. Sample size and the width of CI. Variability in a random sample directly influences the width of the confidence interval. A larger spread implies that it is more difficult to reliably estimate population value without large amount of data. Thus, as the variability in the data increases, the confidence interval also widens. So, in general, we are following these steps in testing of hypothesis. First of all, we try to understand the problem. Then we frame the hypothesis, both null as well as alternative hypothesis. Then we identify the test, accordingly test statistic as well. Then we consider a given level of significance. Then on the basis of test statistic and level of significance, we are taking our decision. That means statistical decision. And on the basis of a statistical decision, we make conclusion. So this is the brief about testing of hypothesis. Here are some very good books for reading this concept. Please go through it if you get time. And if you have any questions, please feel free to connect with me. I will be very happy to answer all your queries. Thank you.